Hello class, welcome to Algebra Concepts Lesson 4-5, which is all about arithmetic sequences. By the end of this lesson, you should be able to write and graph equations of arithmetic sequences. All right. So first, let's talk about a little bit of vocab. What is an arithmetic sequence? It's when you have a pattern that increases or decreases at a common rate, okay? And that common rate is called the common difference. So if we look at a couple examples, going from 22 down to 17, that's minus 5. Going from 17 down to 12, that's minus 5. So it's when it's always changing by the same number, and that's called the common difference. It could also be where it's increasing by the same amount. So in this case, you can see if you add 8 to each number, you get the next number. So common difference is something that's really important that you remember that vocab word, because if you don't know that, there are going to be parts of the video later on that you maybe get a little lost or confused on. So make sure that you jot down a note about what a common difference is. And something else to note, it's called a common difference. And I know sometimes we associate difference with subtraction. So in this case, it just means like what it's changing by. So it can be a positive or a negative number, or you can think of it as addition or subtraction by the same amount, okay? It's no matter what, whether it's adding or subtracting, it's a common difference. All right, so example 1, identify arithmetic sequences. So the first part of today's assignment, today's lesson, is just trying to figure out, is this an arithmetic sequence? And the way you tell that is, does it always change by the same amount? So if we look here, going from 17 to 14, I say minus 3. To go to 14, from 14 to 10, I would say minus 4. So right there, I can already stop. I don't have to test all of these numbers because these two numbers don't match. Some people might write out all of the numbers and say, well, it goes 3, 4, 3, 4, so that is a pattern. Maybe that means it's an arithmetic sequence, but that's not true. They always have to be the same amount. It can't alternate like this, okay? So this is not an arithmetic sequence. Okay, so now I want you to look at these numbers and determine if it is an arithmetic sequence. Good luck. All right, for this problem, hopefully you determine that yes, it is an arithmetic sequence because it has a common difference of minus 9. Okay, so that would be, yes, it has a common difference of negative 9 or subtracting 9. And justify your reasoning, that's what I did right here. So I said, yes, it is, and then I justified. Yes, because it has a common difference. On the last slide, I should have said not an arithmetic sequence because it doesn't have a common difference. Okay, so that's what I would write. Okay, now let's jump to example 2, finding the next term. So determine the next 3 terms in a sequence. So the first thing you got to do is figure out what are we changing by. So 11 to 7 is minus 4, 7 to 3 is minus 4, 3 to negative 1 is minus 4. So if I subtract 4 again, my next number is negative 5. And then negative 5 minus 4 is negative 9. And negative 9 minus 4 is negative 13. So those would be my next 3 terms in the sequence. I just keep that pattern going. Okay, so this is another type of problem that you'll be doing in today's assignment, where you just find the pattern and then you extend it. So why don't you go ahead and determine the next 3 terms in this sequence. Good luck. Okay, hopefully you figured out that the next 3 terms are negative 8, negative 21, and negative 34, because I found the common difference was subtracting 13, so I just continued subtracting 13. If you have questions about that, please be sure to ask for some help. I'm happy to help you. And now let's move on to the next kind of like type of problem, and that's to be able to find like the nth term. So when I ask you to find the next 3 terms of a sequence, that doesn't seem too bad, right? But what if I asked you to find the 100th term? You would probably be really frustrated with me and say, can I just, like, how much would it affect my grade if I don't do this problem? Because no one wants to sit and calculate out the 100th term, right? So there's a shortcut method, and that's using the arithmetic sequence, like the formula for it. So what you need to make sure you highlight, I'm just going to write it a little bit bigger from that key concept. Okay, so that's our formula. Okay, so now what you need to know is n represents the term number you're trying to find. So if I'm trying to find the 100th term, n would be 100. Okay, and then if I have a subscript 1, that means the first term. So what was the first number listed in that sequence? Okay, and then D is your common difference. Okay, so maybe jot down these notes. This is going to be a great thing to have on a note card. Sometimes students end up mixing up the formula if they don't have it on their note card. So please make sure that you write this down. Practice memorizing it, but if you don't get it memorized, make sure it's at least on your note card for the test. Okay? Now, let's use the arithmetic sequence, -4, -1, 2, and 5 to complete the following. First, we want to write an equation. So again, I'm just going to write down what that equation was, and I'm going to show you how we do that. So, saying a of n, okay, so that's how you read kind of that subscript, that just stays there when you're writing the equation. Okay, that's kind of like a y equals, but specifically for an arithmetic sequence. Okay, so a of 1 is our first term. So what's the first number in this list? It's a -4. Then I say plus, and I do parentheses. N minus 1 always stays in your equation. Okay, and then D gets replaced by how is this changing? So to go from -4 to -1, I added 3. To go from -1 to 2, I added 3. From 2 to 5, I added 3. So my common difference is 3. So that's what I would put right there after the parentheses. Sometimes students ask, can I put this 3 in front of the parentheses? And yes, that's totally fine. If you wanted to write it where you said a of n equals -4 plus, and then you did 3 parentheses n minus 1, that's totally fine. Just be careful that you don't add these two numbers first. You need to distribute first before you do anything with that -4. All right, so now if we want to find the 16th term of this sequence, are you sure? I have to edit my video anyway. Okay, so if we want to find the 16th term of this sequence, we're just going to plug 16 in wherever there's an n. So I say a of 16, and there's no calculation that has to be done right there. All that tells me is that I'm solving for the 16th term in the sequence. Sometimes students make the mistake of making this like a 16a or something, but it's not. You just leave that 16 off to the side. And then what we're going to do is we're going to just plug 16 in where that other n is. So then I say -4 plus. I know you guys are more accustomed to having the number in front of the parentheses, so I'm going to stick with that. And I'm going to say 16 minus 1. Okay, now I just have to solve from there. So I say a of 16. I don't change that because that's just like a y equals. And I say 4 plus, and then 16 minus 1, that's really just a 15, right? So 3 times 15 is 45. So a of 16, or the 16th term, equals -4 plus 45, which is 41. And that's how I would solve that problem. Okay, so I wrote an equation, and then I solved for the 16th term. I highly recommend having an example like this written down. All right, now, your turn. I want you to write an equation for this arithmetic sequence, and then I want you to find the 26th term. Okay, so on your ed puzzle, it's going to be 2 separate questions. The first time the video pauses, you're going to write the equation. Then the second time the video pauses, you're going to write your 26th term. Okay, good luck. Okay, so hopefully for your equation, you wrote something like this where you said a of n equals 10 plus 5 plus 10 plus 5 times n minus 1. Okay, If you put this second 10.5 after the parentheses, that answer is also correct. But now I want you to take a minute and find the 26th term of the sequence. Good luck. All right, for this problem, hopefully you said that the 26th term was 273. Okay, so I got that by saying 26 minus 1 was 25. 25 times 10.5 is 262.5. And then I added another 10.5, and I got 273. Okay, so if you have any questions about either of those parts of the problem, please be sure to ask for some help. I am happy to help you. All right, let's take a look at our last example for today. We have Monique opened a savings account to save for a trip to Spain. With the cost of plane tickets, food, hotel, and other expenses, she needs to save $1,600. She opened the account with $525, and every month she adds the same amount to her account using the money she earns at her after-school job. From her bank statement, Monique can write a function that represents the balance of her savings account. Then find how many months it will take Monique to save for her trip. Okay, so if we look at this screenshot, we have a picture of Monique's bank statement. Okay, so if we look, we can see that she started with $525, and then after the $525, the next month she had $580. So that's an increase of $55. And the same going from $580 to $635 and $635 to $690. So I know that my common difference is 55. So I'd say 55. All right. So now my equation, I would say A of n equals 525 plus, and then my common difference is 55, and then I have n minus 1. And that's my equation. So that's the first part of this problem. Then the next part of this problem is just slightly different than what we've done so far. The second part is, what if we don't know what term we're trying to find? So if we know that the total is $1,600, you plug that in to the A of n, and then you'd say 525 plus 55, and then n minus 1. So anytime you're trying to find like what term number is, or you're trying to find like how long something takes, this is where you will set one of your numbers equal to the equation. And then if we look at that, I would say 1,600 equals 525, and I'm going to distribute that 55, so that becomes a 55n minus 55. And then I can combine my like terms. So I have a regular number. So I have 1,600 equals 525 minus 55 is 470. So I say 470 plus 55n. And then I subtract 470 from both sides, and I'm left with 1,130 equals 55n. And then to get n all by itself, I would divide by 55 on both sides. And I get 20.5 if I round to the nearest 10. So it's going to take Monique 20 and a half months to save for her trip to Spain. Okay, so that is how you kind of do it backwards from what we were doing for the rest of the video. It's where you're trying to solve for n instead of solving for a certain term. Okay, so if you have any questions at all, please feel free to reach out for some help. I'm happy to help you, and I hope you have a great day.